Greetings, Graham again. In this clip, we're going to review the four sort of marginal analysis cases we considered with the queuing analysis. That was switching from base case with 10 baristas to 8 baristas, switching from the base case, switching out all the clovers for valves with no training for the baristas. Then same thing, but with training. And then finally base case, but then changing to pooling. And then to sort of like close it out, maybe just we'll try one composite scenario just to give you a sense of how that might look. So what will remain is essentially that you'll have to pick through and make your own choices, for the composite scenario and motivate that with, some analysis. All right, so let's go back and have a look at our base case and see what we need to change here. Let's move my Zoom window around here. Okay, so mean service rate 65 looks good. We're in a base case, but we're moving to 8 baristas. So recall that we have 240 total arrivals per hour. If we're going to serve that with 8 baristas, that's going to mean it's 30 per hour. So I'm going to just change that. And the standard deviation of the service times for valves, which is not relevant here, 35. Number of valves 0, number of clovers 1, because we are analyzing one of the baristas sort of independently. And then the service time is 20. So I'm going to run 3 quick iterations, record those. We'll upload this to the transcript when we're done. So go ahead and run this. So I think we got about, 0.54 for the 54% utilization, about 1.78 or so for the waiting time in system. So I'm just going to run this to completion. And I got a 1.8, which is real close to what we had earlier. So utilization here is 54%. I'm going to go with this number here, 0.541. And then just stop it and rerun it. Run it again, sorry. And then run it to completion. So this time, again, 1.8. So notice that the worst case here is, it looks to be around 6.2, maybe 6.3 minutes. Yeah, there's almost nothing beyond 8.6. All right, so this one, 552 on the utilization, just using this to build confidence intervals. Run it again. And this time it's 183 and 55. Great. So that's the 8 barista solution. And you'd have to, again, consider 9 and 11, 7, 6, 5, to figure out where you want to land this. And you'd have to present all of this to Carlos so that, there's no missing counts there of baristas that would beg questions. So let's go back to our base case. There it is. And for the next one, we're going to switch all of the clovers to valves. So there's no clover now. Instead, our barista has the base case has a valve. So all I need to do is just change that. And I can go ahead and run. And it'll speed up to the end. So here we were expecting 43% utilization, got 44.1. And we're expecting 1.62, although at least that's what we got for the queuing here, with 169. So good, just to do our second iterate, knock this out. So now we got 172. And a valve utilization of 456. Notice how the clovers have no recorded utilizations. And again, probably looking at about, what is this? 6.97 minutes would be like really the high end of the service time distribution. One last one. through it. So 172 again. And this time 452. Great. Now let's go and train the baristas. So on the service time for the valves, now it drops to 10. Okay, everything else remains the same. Run this. Speed that up. So we get 1.50 apparently. 4.422. Stop, run. 152 this time. And 0.437. Oh, sorry. Shouldn't have done that. Needed the third one. Here we go. This is going to be adequate. You don't need to sort of like stop and run it again. This is fine. So this is 153 and 443. Great. So now we're ready for our last one. Now we're back at now we're pooling. So now we're going to serve 240 customers. We're back with the valves. So and we're assuming that the folks are not trained. So there are in fact 0 valves and there are 10 clovers. So that should be the setup. Going to run this to completion. Expecting a number of around 1.08. That's a release we got from the queuing, 43% utilization. So I only got 40.9% here, 109. And you can see the worst case is probably around maybe 2.4 or 2.5, somewhere around there. When I say worst case, like a fraction of 1% would be worse than that. So we stop and run. So 109 again. Really? Did I get, if I did that, let's just try that again. Okay, so 408 and 109 and stop and run. But this is very tight. 407 and all of them are 109. Awesome. Okay, so just to give you an idea of a composite scenario, let's consider what we're going to do here. I'll try 7 baristas with training and working a mixture of 5 valves and 5 clovers. How's that? So let's get the clovers and the valves in. So I need to drop this to 10 service time on the valves because let's assume that if they have a valve, they're going to be trained. So everybody's trained, let's say. 5 valves, 5 clovers. So this is 10. Now, I need to figure out what the total, so they're not pooled, excuse me. All right, so, okay, so that doesn't make any sense. Let's assume they are pooled and that there are only 7 baristas. And let's suppose there are 4 valves. So the 240 is correct. 4 valves and 3 clovers. But let's suppose they're not trained. How's that? Change it up. Right. So again, our scenario here is 7 baristas, no training, but pooling. Okay, I think we're good. We run this. And speed it through. So final scenario gives us 118 with 43.8%. So notice I do have 7 baristas. Okay, so there's a blend here. I need to be careful. And I'm just going to So actually, you see there's Clover utilization, that's 0.438. And the valve is 715. The reason that for the discrepancy is because if there is a free valve, it goes for that first. And the high end here is around about 3 minutes on the 3.2 minutes on the worst case service time. So I'm going to stop and run that. And here I get didn't run it to completion, sorry. There it is, 427 and 709 and 117. Worst case again looks to be low threes. Yeah, 3, something like that. So we could compute a weighted average of the utilizations if you wanted to just get a simple utilization number. And what I do there is I take 4/7 of the VAB number, 3/7 of the Clover number, and that should give us a reasonable look. Here I've got 118 again, and 438, 715. Okay, so let's go into our annotation here. I've got this set up. I'm just going to plug them in, all of our data. I'll bring you back when I've populated, and then I'll just show you what I did with the transcript. Great. So wrapping up here, I populated the numbers that we recorded during the simulations in the table here. I did get a single utilization number by taking 4/7 of the VAV numbers here and 3/7 of the Clover numbers, because we had 3 Clovers, 4 VAVs, and I plugged those in here. Don't have any queuing numbers for this because we can't analyze mixtures of Clovers and VAVs in the queuing model. And then finally, I took this information and I ran a prompt here. I took that table and I said, give me a confidence interval for the simulation WS and simulation utilization in the following table. And I just cut and paste this table here. And it managed to do that. We'd have to verify, in fact, if it did give the correct numbers. You can do maybe just check with one calculation, take 3 numbers and just run the 95% confidence interval. And then I pulled that into the chain of thought here by just reporting what I did. So let's just see. Ran the analogic simulation model 3 times. Run that prompt in Perplexity. I cut and paste the output from Perplexity in here. There it is. There are those confidence intervals, including all the references. And then I just sort of summarized what I did finally here. And I copied that table in from Google Sheets. That's it. Hope you this will help you make sense of the ACG case. Looking forward to seeing what you're going to do with this.